Hello everyone, my name is ZHAO Haibo, an algorithm engineer working for PIESAT company. It is a pleasure for me to present an introduction for our company and some of the products and real-life projects our team have done. PIESAT Information Technology Company Limited was established in 2008. It is a leading satellite operation and application service provider in China. PIESAT is committed to the localization of satellite application software, industrialization of application solutions, and commercialization of customized service. PIESAT has independently developed a series of software products and core technology called PIE, which stands for Pixel Information Expert, and provided professional service to governments, enterprises, and universities. PIESAT was listed on Chinese Science and Technology Innovation Board (STAR Market) in July 2019. It is the only remote sensing application enterprise among the first batch of enlisted enterprises on STAR Market. PIESAT has actively participated in national strategic One Belt and One Road initiative, providing satellite data processing and application service for those countries. PIESAT has established subsidiaries in many countries around the world, including London, Sydney, Geneva, New Delhi, and other parts of the world. PIE software has been localized into English, Russian, Mongolian version, and it is promoted and trained in United Nations, Pakistan, Turkey, Mongolia, Bangladesh, Iran, and Peru. Here I want to introduce PIE Engine software, its application and data capacity. PIE Engine is the flagship software product of our company for satellite data processing and remote sensing solutions. PIE does not only provide comprehensive function for processing multimodal remote sensing data, for example, optical data, radar data, hyperspectral and LiDAR data, but also implement cutting-edge AI technology for information extraction, providing a highly automated and user-friendly platform. PIE hosts the exclusive intellectual rights of PIE software. There are several modules for PIE Engine, which are PIBasic, which offers the basic GIS functionalities, PIORSAL, a software for land survey using remote sensing images. PISAR is SAR data processing software. PIHype is a hyperspectral data processing software. PIUAV is a software for UAV data processing. PICS is an object-oriented image segmentation and classification tool. PIAI is an intelligent interpretation software. PIMAP is a 2D and 3D visualization software. PISDK is the secondary development kit providing agile development ability of GIS software. PIEngine is a cloud service platform based on cloud computing, Internet of Things, big data, and AI technologies. It is a cloud computing infrastructure which is able to standardize software integration and operation for multiple industrial disciplines. The platform covers the entire processing stages for spatial temporal data, which include collection, storage, calculation, management, application, providing a one-stop cloud plus local service. It provides online multiple source data production, processing, intelligent interpretation, analysis, as well as industrial-oriented CS application services. In order to maximize the value of massive remote sensing data and promote the industrialization of remote sensing applications. There are over 100 datasets, 3 petabytes of data, 7.5 million scenes of data currently available in our PIE Engine Cloud, which include Landsat, Sentinel, Chinese Golfin series, MODIS, Himawari 8, and other useful Level 2 and Level 3 data. Multi-terabytes of data is added to the database regularly on a daily basis to keep the database up to date. Now, I'll introduce some of the real-life projects my team and I have done in the past years. This is a project our team have done for the China Meteorological Administration, which involves typhoon monitoring and intensity estimation using geostationary satellite Fengyun 4. Using the AI algorithm, typhoon position and intensity is retrieved. Using infrared imager onboard Fengyun 4 satellite, the statistics of different typhoon phenomena is shown in the left panel, which includes center surface pressure, maximum sustained wind, moving speed, path vector, etc. Intuitive GUI and ancillary data is overlaid on the Cloud Atlas, providing comprehensive information of typhoon life cycle in a single web page. The typhoon training data pairs are generated from typhoon bath track reanalysis and collocated Fengyun 4 11-micron channel observation. ULV4 model is adopted to train typhoon detection neural network. For the region of interest generation, VGG network is used to generate detection frame, and regional proposal network is used to generate ROI frame. Finally, ROI pooling layer is used together with following convolution and full connection layer to detect typhoon position and ROI frame. The above images shows the automatic typhoon positioning results. With this method, pre-trained detection neural network, there is no need to rely on typhoon reports. This is the Typhoon application app developed by our team. As you can see, useful information including typhoon satellite imagery, typhoon track, center position, center minimum pressure, maximum sustained wind speed, cloud top temperature is shown. This app can provide comprehensive information pertaining to typhoon positioning and intensity estimation. Now let me introduce some of the works our team have done for the pollution monitoring application. One of our main services is to provide air pollution monitoring capability to various government agencies. This website shown here is developed for China Meteorological Administration. Aerosol information is retrieved from Fengyun 4 imager AGRI, including aerosol optical depth, haze optical depth, surface PM 2.5, PM 10. One of our main services is to provide air pollution monitoring capability to various government agencies. This website shown here is developed for China Meteorological Agency. One of our main services is to provide air pollution monitoring capability to various government agencies. This website shown here is developed for China Meteorological Administration. Aerosol information is trained from Fengyun 4 imager AGRI, including aerosol optical depth, haze optical depth, surface PM 2.5, PM 10, air quality classification, and multi-scene composite. Random forest algorithm is used to establish seasonal AOD versus PM 2.5 relationship, and near-surface particle concentration and distribution. Input data include Himawari 8 AHI, Terra and Agua MODIS, Fengyun 4A AGRI, MPP VIRS data, with the NWP atmospheric parameters, including surface pressure, temperature, wind speed, wind direction, relative humidity, and visibility. 70% of the data are used for training and 30% are used for validation. Daytime seasonal retrieval results shown in the above figures. Using the trained AOD versus PM 2.5 model, PM 2.5 concentration for 4 seasons is calculated. Comparison with ground truth shows correlation coefficient is over 0.95, and the RMSE is less than 15 microgram per cubic meter. Nighttime retrieval of PM2.5 have done using long-wave infrared observations. Counterintuitively, aerosol property can be retrieved using long-wave satellite observation. Sensitivity study have done using radiative transfer function CRTM with different aerosol optical depth. Results show long-wave channel will have 3 to 5 Kelvin response. For nighttime retrieval, hourly RMS error is 19.3, daily RMS error is 9.7, monthly RMS error is 4.9, seasonal RMS error is 3.9. Different machine learning methods has been tested, including random forest, XGBoost, and deep learning neural network. Random forest and XGBoost have comparative performance with R-square about 0.8 and RMSE about 8.3. CNN performance is a little inferior compared to both random forest and XGBoost, with R-squared about 0.7 and RMSE about 10. With our daytime and nighttime aerosol retrieval algorithm, we developed an air pollution monitoring solution using multi-source sensors, including satellites, UAV, LiDAR, ground-based stations, vehicle platform, microsensors, etc. The final composite product is upgraded into 1 km by 1 km resolution based on different thresholds for different pollutants. The final pollutant heat map is generated. Combining with high-resolution satellite imagery and emission list, for example, the position of a power plant, the position of pollutant source can be determined. This information is then passed on to local environmental enforcement agencies. Now, I will introduce some of the works our team have done in the fire monitoring application. This website shows our fire monitoring solution, including in situ surveillance camera on left panel, satellite imagery in the center, fire detection statistics in the bottom, and satellite data source in the right panel. Over 10 satellites are used to provide fire monitoring solution, including geostationary satellites, for example, Himawari 8, Fengyun 4, and polar orbiting satellites, including Fengyun 3B, C, D, MPP, Terra, Agua, etc., offering high temporal resolution up to 10 minutes per scan. Visual and IR surveillance camera is deployed on key areas to provide all-weather, all-time fire monitoring capabilities, and also providing additional monitoring capability for small fires. Our fire monitoring solution provides a comprehensive and rapid response service to authorities. Some of the highlights include multidiscipline data integration, AI automatic fire detection, customization based on users' needs, 24-hour support from our professional staff, using data from multiple satellites to achieve high temporal frequency, proving fire detection algorithms for each satellite, all-weather, all-time monitoring with complementary visual and IR video feeds. Based on captured video, ULV4 object detection model is used to identify fire. ULV4 is a fast and accurate, which provides the capability of training highly precise object detector with a single 1080 tie or 2080 tie graphic card. The fire detection results using ULV4 is shown in the above figures. Using the visual imager and IR imager on board UAV, fire incidents can be detected rapidly on a very large area. The visual and navigation information is fed back to the fire monitoring console, providing valuable information to the local authorities. Some of the characteristics of this solution include self-developed UAV platform, professional UAV controller, payload is customizable by request. Based on the information provided by our solution, Probable fire instance is reported to local fire department, and further validation is carried out by a professional team. Mobile app is developed by our company to facilitate ensued fire. Based on the information provided by our solution, probable fire instance is reported to local fire department, and further validation is carried out by a professional team. Mobile app is developed by our company to facilitate ensued fire alert processing. Now I will introduce some of the weather and ecology application our team have done. Our team has developed Fengyun 4 application software used for weather analysis. It is a web-based software whose function includes day and nighttime cloud microphysics composite, fog and snow composite, air mass composite, natural color composite, dust composite, etc. Objective interpretation of cold front, warm front, occluded front, extratropical cyclone, convection identification and tracking, convection initiation monitoring, lightning imagery data processing and visualization, West Pacific typhoon positioning and intensity estimation, quantitative precipitation estimation. Here are some of the works we have done for ecology and environment applications. For example, satellite monitoring of vegetation, blue algae, drought, and water body. Well, this is a brief introduction of some of the works we have done. I want to conclude this presentation with the motto of our company: serve the Earth and space community. Thank you for listening. Please feel free to contact us via phone or email, or you can visit us at the above address. 这有点磕巴。